It's been nearly 40 years since anyone has set foot on the moon. But in the next decades, U.S. astronauts will return. And this time, they plan to stay.
It's not the same old program again. It really is a lot more ambitious than anything we've ever done before.
Survival is far from guaranteed. There's no air, food, or water, just lethal doses of solar radiation and razor-sharp dust. So what will it take to make the moon inhabitable? And do we have the technology to pull it off?
Now, we have machines that we never would have dreamt of in the 60s.
Living in space has always been the ultimate science fiction dream. For this generation, the future is now. It is one of the great adventures of our time, a life in space, and it's coming fast. In less than 20 years, humans will be making a home on the moon. That's what NASA's planning in their new vision for space exploration. By the year 2020, dozens of teams will begin arriving. Their goal, to create mankind's first outpost in space, a base camp on the moon. But just to survive there will be one of the hardest tasks science has ever undertaken. The moon's hostile environment not only lacks all the things we need to survive, the dust that covers it is potentially lethal if inhaled. Establishing a lunar base will be like a mission impossible. To pull it off, scientific teams across the country are now working on groundbreaking new technologies. From next-generation robotics and remote sensing to state-of-the-art advances in navigation and life sciences. Will they be able to reinvent space exploration within a decade as planned? Their timetable has already begun. It all starts with an unmanned mission slated for 2008. It's our first trip back to the moon in years, and NASA's plans for a lunar base are riding on it. On board is the Lunar Reconnaissance Orbiter, or LRO, our map maker. If LRO fails, so will everything else. Because before we can build a base, we have to figure out where to put it. And on the moon, as on Earth, the three key factors are location, location, location.
Well, right now, the best maps of the moon were made by the Clementine Orbiter in 1994 and the Lunar Prospector in 1998-99. The problem is they're incomplete and they're relatively low resolution, but they're very good. In order to really understand the real estate we want to go to, we got to do better.
LRO's vital mission is to map the moon in detail using advanced lasers. Up until now, the best moon maps have only been accurate to within a dozen kilometers. But LRO will go down to the nearest 100 meters. Without it, knowing precisely where to place a shelter or anything else on the moon would be next to impossible. The 6 previous moon landings stuck strictly to the lunar equator, where the surface is flattest, the best place for a safe landing. This time around, the most important criteria of where to land will be what they can find there, specifically mineral resources. That's because no long-term manned lunar mission will be able to survive based only on what they bring along.
Imagine packing for a camping trip and packing 50 gallons of water for 2 weeks, because there's none, and your 50 pounds of food, and your 50 pounds of packs. Well, that's a lot of packing. Every ounce, every gram you take into space costs money because you have to launch it and get there and land it.
In space, survival boils down to a small but critical checklist of essential items. First and foremost is oxygen. Oxygen is not only crucial for breathing, but it's the primary ingredient in rocket fuel. NASA teams will first need to know where the oxygen-rich rocks are located, even before they devise a way to extract it. To find these minerals from 250,000 miles away, researchers at the Goddard Space Center in Maryland have come up with a novel solution: the Hubble Space Telescope. For over 15 years, Hubble has wowed the world with deep glimpses into far-off galaxies. Now the telescope turns its gaze a little closer to home. Because what it can do amazingly well is tell Chief Scientist James Garvin where key mineral resources will be found.
Hubble's exquisite ultraviolet vision that we need to map galaxies applied to the moon, we can ask, where are there resources rich in oxygen that we may be able to identify on the moon and learn to use to live off the land? Now, here's something really cool. This is our best map of the distribution of the highest oxygen-bearing soils on the moon.
Shown in blue, oxygen-rich material has a specific fingerprint when exposed to ultraviolet light.
And it turns out, because Hubble sees so well in this ultraviolet part of the spectrum that our eyes don't see, we can use it as a fingerprint finder on another planetary surface.
Human eyes see only shades of gray on the moon, but Hubble reveals a world of vibrant color. Using the color fingerprint from previous lunar landing sites as a key, scientists can locate pockets of oxygen-rich rocks. It's a map to potential lunar treasure.
Because in real estate, location's everything, and that's the way exploration works. Do we want to go back to these places? Do we want to go to this place? Down here to the poles where there could be water ice? Hubble allows us to map what's there and target more precisely where we might want machines and people to go.
Besides oxygen, the other key to life is water. Carrying enough up for an extended stay is not a practical option. So we'd either have to make it once we arrived, or better yet, find it there. Of course, there are no flowing rivers on the moon, but there are hints of where ice might be hidden. Like a crater so deep that no sunlight ever reaches its floor. Shackleton's crater on the moon's south pole. At 300 degrees Fahrenheit below zero, it's an excellent potential ice trap where hydrogen, possibly from water, is known to be plentiful. A second satellite aboard NASA's mission in 2008, the Lunar Crater Observation and Sensing Spacecraft, or LCROSS, hopes to confirm that water ice is there. But before this vision can be realized, scientists must remain firmly planted near San Jose, California, at NASA's Ames Research Center, in the shadow of its historic blimp hangar. About a dozen LCROSS team members have set out to find the fountain of life on the moon. Dr. Anthony Colaprete is lead investigator.
Hey, Kim. So, are we getting set? It's amazing how much such a small little unit will do for you, huh?
Yeah.
Much of their hope rests with this tiny, fragile box supplied by an outside vendor. Once loaded on the LCROSS satellite, it will look for infrared patterns of water in the moon's crater's dust. But since that crater's dust is hidden in a permanent shadow, the LCROSS team thought they'd bring the dust up to them, ramming a school bus-sized rocket shell into the crater, kicking up 500,000 pounds of dust 20 miles into the sunlight so the device can scan for water ice or vapor. But before that happens, the device has to survive the pressures of a rocket launch at 10 Gs, 10 times the force of gravity. To be sure it can, the team is going to subject it to even more.
So we're going to put 14 Gs per axis.
Yikes.
Quite an aggressive test.
Yeah.
It's a very aggressive test.
That's about 1.5 times?
1.4 times
what we
is
expect
expected in flight. Okay. In flight, we're expecting about 10 Gs.
10 Gs, okay.
Mm-hmm.
And we're going to do all three axes?
We're going to do all three axes. Okay. X, Y, and Z.
How long do we shake each axis?
1 minute.
1 minute?
Mm-hmm.
This instrument is a critical instrument to the payload because it is the one primarily responsible for direct measurements of water vapor and water ice. That's why it's in here first. That's why it's shaking, and we're beating it up as much as we are because we want to make it as robust as possible.
35 kVA amplifier for the vibration.
Simulating a rocket launch 14 times the pull of gravity, the amplifier will generate an intense series of tiny, violent vibrations. Rattling the small box bolted onto the table, The vibrations will be nearly 1.5 times as extreme as the launch itself in 2008.
Solid little instrument. We'll see, though, once we shake it real good, we check the calibration, we'll learn a lot how much we need to strengthen it. So this is a really good, quick initial development test that will help us out.
The team can't take any chances. This instrument is too important to the mission. They must make sure it can survive the long journey, because it will have only the smallest window of time to function. Once the satellite reaches its destination, 2 years of planning will come down to just 10 minutes. That's all the time the device will have to detect water and transmit back to Houston. Plunging through the cloud will give it the best chance to complete its mission. But once it begins its descent, there's no turning back. And if the small box malfunctions during that time, its opportunity to detect water will be lost. The satellite will have no power to curtail its trajectory into the moon.
1 minute.
To the naked eye, the test barely seems to shake the device at all. But inside, it's being pounded with thousands of tiny vibrations, each the equivalent of a roller coaster.
Kind of a long minute.
I mean, yeah.
Find out.
They hope for the best.
I thought I heard something rattle.
You heard something?
Yep.
But they soon realize they've got a problem. The outside vendor's device has failed its initial vibration test.
We wanted to see how robust it was to a rocket flight. It's not very robust, apparently. And what they're going to do is open it up, look at the optical design, see what came loose and why, and then reinforce it.
Now the situation is more urgent than ever. They've got less than 12 months before final design, and one of their primary tools to find water is going back to the drawing board. What other tools will NASA have in case this one doesn't make it?
All right.
Spin up the drill.
The answer may lie in some cutting-edge robotics that are being developed nearly halfway across the country. Because if the humans don't have the answers, perhaps the humanoids will. With final designs for NASA's L-Cross Moon mission less than 12 months away, the hope of tracking down potential water sources has taken a hit with the recent failure of one of its key instruments. Luckily for this mission, there are other teams and other devices also in the planning stages. Though the L-Cross satellite will have the best vantage to measure for water, it won't be NASA's only asset reading the dust cloud. The Hubble telescope and the Lunar Reconnaissance Orbiter will both be in position to read the impact clouds. And if water is present, NASA will need a way to find it beneath the surface. In Houston, Texas, at Johnson Space Center's Vanguard Hangar X, another team is innovating a tool many Texans know well: a mineral exploration drill.
Drilling is going to be a really critical tool if we can tap into water resources in the subsurface of the moon. That's going to help enable our human exploration tremendously.
But this is not your average power tool. To locate ice reserves, it must operate for long periods on low power and endure temperatures up to -300 degrees without freezing or cracking. And it also has to be small and portable. Normal steel drills, immense and heavy, would be impossible to get to the moon, let alone use there.
Okay, you're now in.
NASA's exploration drill is slim, cast from light alloys to reduce flight weight and fuel consumption. But is it strong enough to stand up to the moon's extreme environment and penetrate its frozen surface?
Wouldn't it be great if we were sitting in a control room on Earth watching this drill on the moon?
Yeah.
To test it against the cold, the team drills ice in the lab's sub-zero chamber.
What's your advance rate?
Right now we're advancing at 10 inches per hour.
Okay, that's great.
They must press gradually. Too quick and they could snap the bit.
Looks like it's drilling well. You can see the cuttings arguing up out of the hole. We can drill ice pretty quick compared to some of the rocks we drill.
The team now feels ready to test the tool under more extreme conditions. Nunavut, Canada. 2,300 miles north of Houston, the team travels to one of the coldest places on Earth, the Arctic, just a few hundred miles from the North Pole. At minus 40 degrees Fahrenheit, it's not quite as cold as the moon, but it sort of feels like it. This journey to the Arctic will be the ultimate field challenge for the crew and their drill. They're taking it out to the frozen sandstone outcrops of the St. Mill Basin.
This is the sandstone site where we think we want to do our first drilling of the trip.
Can an exploration drill that uses no more power than a reading lamp work out here?
We've got everything set up. We're bringing the bit down slowly, and we're going to do a test, put it into spin mode, and see if the torque motor is working.
All right, enable.
Severe cold makes metal more brittle. So the team must test if the drill can retrieve a core sample without cracking.
Mike, we're about 30 pounds downforce. Auger torque is 3.1 amps, so we're around the 45 inch-pounds.
For 30 straight minutes, the tool bores almost a foot into rock in sub-freezing temperatures. The drill doesn't crack. Now they have to see what it's achieved.
Yeah. So here's our first core, sandstone in the Arctic. And it's a pretty clean break.
It's a good first step, but eventually the team will have to certify the tool can drill deeper, for longer, and in temperatures not found naturally on Earth. Scientists hope their extreme efforts will pay off for lunar settlers in the next decade. But NASA also knows there will be some places simply too cold, too inhospitable to send astronauts to drill. That's why they have another plan in the works to secure potential water ice or other resources from the moon itself. Advanced robots are now being developed to work in regions too hostile for humans. One team is working on the problem. In Denver, Colorado, at Lockheed Martin's Spacecraft Technology Development Lab. Here, scientists are developing a new breed of robots, rugged excavation prototypes to endure harsh environments for long periods. On the moon, machines extracting resources will play a vital role. They could mean the difference between life and death. Breakdowns would be more than just inconvenient. For starters, robots would need to endure a 600-degree range in temperature without lubricants in a dusty environment. And that's the easy part.
The real complexity involves the timing and really the self-location aspects. This robot has to know where he is in relationship to the lander and to the spot it wants to dig. It has to know what hazards are in the way, and then it has to make the decisions to get there by itself. That technology is being developed, but it's not entirely perfected yet.
Though smart sensory feedback and self-correction are advanced robot brain behaviors, the real sci-fi dream would be to deploy robots with human capabilities. That's where NASA's Robonaut comes in. Like something out of Star Wars, Robonaut is a virtual humanoid. Robonaut solves the problem of sensory feedback by utilizing human brains. It can be controlled by an astronaut from the safety of a capsule or from thousands of miles away on Earth. Originally designed to work outside of the space station and shuttle, Robonaut can also work in tandem with astronauts as an assistant in maintaining equipment, finishing repairs, and completing repetitive tasks. Robonaut really will be able to go where no man has gone before. Through a stereoscopic virtual reality screen and movement sensors that position its head and arms, the robot can see and manipulate tools as its operator does. Also equipped with LEDs for night work, darkness won't limit activity. Robonaut is an innovation only dreamt of half a century earlier, before any man or robot had been to the moon.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
In July of 1969, just 7 years after President Kennedy's speech, NASA and Apollo 11 met his impossible challenge. By December 1972, astronauts had returned to the moon 5 more times. The last, Apollo 17, included geologist and space pioneer Harrison Schmitt, the 12th and last to step onto the moon. So far.
We developed an insight, I think, into what human beings can do with modern technology if they just put their minds to it. Apollo seemed like an unreachable goal when it was articulated first by President Kennedy.
Those lunar missions revolutionized our understanding of the universe and ourselves within it.
The valley of history has seen mankind complete its first evolutionary steps into the universe. It's not often that you can foretell history, but I think we can in this case.
Based in part on the Apollo missions, astronomers got a much clearer insight into the moon itself and how it was formed. Most believe the moon began as part of the Earth, torn off in a terrible collision.
Very early in Earth's formation, planetoids, something the size of current-day Mars, impacted the Earth and splashed off a large portion of the Earth. That splash would have been vapor and molten rock that eventually orbited the Earth, cooled down, and coalesced gravitationally into what is now the moon. There's a lot of evidence for this that we see in the moon.
For one, the moon wobbles like a lopsided basketball. As it formed, molten clumps of rock deep inside were pulled together towards the Earth. After cooling, these dense clumps exert greater gravitational pull on passing objects, like satellites or spaceships. If the theory is right, and the moon was once a small piece of the Earth, then how can the next settlers make it feel like home? Nearly 850 pounds of lunar dust and rocks collected on Apollo missions may hold a clue. Housed at Johnson Space Center's Lunar Lab, some are similar to rocks found in Hawaii. This one looks like basalt, cooled quickly after lava flow.
Okay, so let's start with it lying flat.
Others are filled with an element found in large supply on Earth, oxygen. But how can you squeeze the oxygen out of a rock? That will be the challenge for the next generation of astronauts as they attempt a modern-day alchemy, pulling oxygen and water out of a stone. Oxygen and water will be keys to survival on the moon. But no one's sure they'll be able to find water in the dust. If NASA fails to find it, researchers are developing a remarkable new method to make water from the dust itself. Moon dust is actually more valuable than diamonds or gold. It's far too expensive to experiment with in large quantities. So here at the Colorado School of Mines, technicians create a substitute known as lunar simulant. They take volcanic rocks, the closest thing to moon rocks on Earth, and they crush them. Then they remove any organic compounds. Once pulverized and cleaned, the lunar simulant is shipped to labs across the country, like Lockheed Martin's in Colorado. As with real lunar dust, or regolith, this simulant is rich in oxygen.
5.02 grams, 5.02.
If scientists can find a way to squeeze out the oxygen, astronauts could use it not only for breathing, but also combine it with hydrogen to make water. The method is called hydrogen reduction.
Okay, Larry, we're good to go.
They place a small amount of the simulant into a reactor and heat it to 1,000 degrees Celsius. Then they add a little hydrogen. And just like that, they get H2O, water from the dust.
Bruce?
Yep.
How's it going?
It's going good. Actually, a really good run today.
Excellent. How much water did we get?
It looks like about 0.04 milliliters.
How much soil did you put in there?
5 grams.
Is that freezing level? Is that what that is?
Might have the condenser a little too cold.
Yeah, I don't even get too cold.
Once cooled, the water can be used as is, or broken back down to create oxygen.
Good results.
What we're trying to show for NASA is that we can actually provide a complete self-contained oxygen-producing system that's completely independent of all human intervention, that can be launched before the humans get there and provide a pre-positioned cache of supplies so that we can sit there and percolate away, make oxygen, store it as liquid oxygen, and when the astronauts arrive, they can have a safety cache that they could just plug it into their habitat and live off that for a longer duration.
Yeah, we're very interested in something called ISRU, in situ resource utilization, basically living off the land.
When the astronauts set out to return to the moon in 2020, they will have one of the trickiest jobs in the history of exploration, but one of the most vital: building shelter on the moon. What might a moon base look like? Back at NASA's Hangar X in Houston, engineers are pushing the concept of a mobile home to its limit. They're working on a vertical cylinder, a townhouse for the moon. Like a spaceship, any lunar habitat has to be pressurized. Cylindrical walls help retain that pressure and distribute it evenly. Air pressure is just one of dozens of factors that Chief Habitat Architect Chris Kennedy and his team have to consider.
And where are we at with the emergency lighting?
Even more basic is the orientation: vertical versus horizontal. It's much easier to land a vertical habitat on the moon, though a horizontal habitat offers more flexibility of use. To overcome the problem of landing it, perhaps the horizontal could be made from more flexible and easily packed material, maybe even something inflatable.
A lot of the design is driven by the volume that launch vehicle can deliver. And that's where sometimes we start thinking outside the box, like looking at inflatable habitats. So we package them up in a smaller volume, and we would take them to the moon or into space and then deploy them, and then thus you have a larger volume to work with, giving the crew member more free volume, more habitable volume for them to live in and to work in.
What would it feel like to live in one of these habitats for an extended time? What would make the perfect home on the moon? To find out, NASA's designers asked someone who's lived in space, astronaut Mario Runco.
This was great to provoke a discussion, to get people thinking about, is this right, is it not? Is the crew quarters large enough? Because if you have it on a drawing, oftentimes you don't get the concept of how spacious or small it is, but when you actually have it physically laid out, you can say, well, this will work or this won't.
We didn't want to go too far down the road with our design ideas and such, so we didn't build it out of aluminum and steel. We outfitted the whole place in just this cardboard foam core. The habitat was designed around 4 crew members. This bed is weight bearing, so you can go ahead and get on it. Mm-hmm. So, yeah, it's done. If this one would be your crew quarters, you have your work surface area, you've got your window.
And we'll make this the crew quarters on the other side by sliding this down, and now it would be the mirror image of the other room.
This is our smallest volume crew quarter, so we combine the bed with the desk.
People go into their bedrooms or their crew quarters. That's private space, but most of the activity is going to be done here. And so this place needs to be someplace that is conducive to being in. You want to be here, you'll feel comfortable. You know, this was our flat screen TV. Right. In the evening, for social times, you could be watching movies here. In the daytime, you could be talking with Earth. Right. Food. What kind of food are we going to have? We have ISS, International Space Station, kind of food right now.
The food packaging that we have now for space is optimized for zero-G. You insert water with a needle and you rehydrate it that way. And on the moon, you're going to have gravity. Yeah. Sinks and faucets and dishes, and it doesn't make sense to eat your vegetables out of a package like this. You're going to put them in a bowl and eat them with a fork and spoon.
And maybe they'll be freshly picked from a lunar garden developed in NASA's Life Sciences Lab. These hydroponic gardens grow plants in nutrient-rich solutions, not soil. Plants will be key to any life in space, not just for fresh food, but also to produce oxygen, absorb carbon dioxide, and naturally filter water. Other tests show that living with plants can reduce stress, an important psychological plus for those cooped up in a tube for 6 months. The effects of space habitation have been tested for 20 years aboard the International Space Station.
This Commander Scott Horwitz, as he begins to open the hatch into the station.
The pioneering facility has provided invaluable information for researchers on both the psychological and physical effects of living in space long term.
If we want to operate on the moon for extended periods of time and get the most value for those missions, we're going to have to learn how those people are going to be able to operate for 1, 2, 3, 4, 6 months at a time on the lunar surface. We're doing that kind of work in microgravity today on the International Space Station.
That experience has taught NASA that even astronauts in peak physical condition can have problems. Life in space takes a toll on the body. With little gravity pushing on them, their muscles atrophy and bones can shrink. Only the most rigorous exercise programs can help combat those effects. Kidney stones can also occur since gravity is not there to help organs flush solids out. And when real medical emergencies pop up, that's when things get serious. There will be no 911 responders on the moon.
On a shuttle or the station, you can get a crew member back within a day or so. But going to the moon, you know, you have at least a 2 or 3 day transit time in between there, so you want to think differently about your medical care.
Eye trauma from caustic lunar dust is also a serious hazard. Having advanced diagnostic tools to find it quickly will be imperative. Ultrasound equipment is lightweight and portable.
And we'll go ahead and put gel on the probe.
It creates images from sound waves bouncing off internal organs and bones. Astronauts will use the device as surrogate eyes for medical specialists to diagnose the crew from Earth.
Okay, I got it.
And now, could you move the probe as close to the nose as possible? That's excellent. And
detecting a condition before it gets critical could save the patient's sight.
I see you did that. Thank you very much. Now, let's focus on the image, please.
With a timely diagnosis, doctors will have the option to perform remote, non-invasive surgery.
That's an excellent image, actually. Thank you, Shan.
Or recommend a 2-day journey back to a hospital on Earth if the crew member is critical. Emergency or not, NASA will monitor the astronauts' health round the clock. Because when living in an environment as deadly as the moon, bad things can happen fast. Ultrasound and remote surgery can do little against the most serious health threat faced by astronauts living on the moon. A threat that'll be all around them: killer dust. In little more than a decade, NASA will send 4 astronauts to live for a week in the most hostile environment ever faced by man: the moon. The lack of water and oxygen will be just the beginning. Even the ground they walk on there will be dangerous. The moon's dust may yield minerals, but it has a dark side. Lunar dust is as sharp as glass shards, piercing as needles.
Okay, and then we got a dusty corner off here. Man, we are filthy.
It clings to everything, and it's potentially deadly.
Lunar dust is really nasty stuff. If you look under a microscope, it looks like shiny little knives. Very, very sharp and pointy.
It's literally been beaten into that wicked shape. For billions of years, meteors have bombarded the moon, cratering its face and pounding surface rocks into ever smaller pieces. Senior scientist Linda Watts explains.
The rock is about 4.3 billion years old, and when it was sitting on the moon, it got zapped, and these little pits are glass-lined craters from particles that actually come in at great amount of speed and hit the rock and vaporize themselves.
Any planet without an atmosphere, you develop this very fine-grained, commutated material that we call the regolith. It is primarily the result of very small meteorites. They're the ones that do most of the glassification, if you will, of the soil.
Now imagine breathing that ground glass-like dust into your lungs. Imagine the damage it could do. It's like silicosis on Earth, the lethal disease that kills coal miners and stonemasons who breathe in shards of rock.
I have never seen anything like this before.
It was avoidable visiting the moon for a few hours, but how will engineers protect astronauts on longer stays? One answer, a mudroom in the lunar habitat.
I guess there would be a grate here, you know, for if I'm going to have some tools to clean off.
Open floor grating.
And then it would drop back down to the surface. And of course, we'd move back inside and seal this up. All right, and then now that we're sealed in here, we can repressurize.
Of course, once you're in this part of the airlock, it'll be cramped when you're wearing your suits, but the first task will be to take the suits off, and they'll still be dusty. There'll still be a lot of dust in here. There'll be arrangements in here, some kind of air filtration system to collect the stuff and make sure you don't breathe it in.
I like the idea of the knee knockers, as we say in the Navy. That's a barrier so that you don't just drag the dust across. You'd clean off here and then step over.
Okay, we put this hygiene compartment here right next to the airlock so that it would be immediately available to crew members. If you need a little water to finish your cleanup, it's right here.
Okay, that's real good, and especially after being outside for 8 or 10 hours, you're probably going to want these facilities.
First thing you want to do when you get your suit off is to go to the restroom, probably.
Beyond the airlock, the best way to protect the men and women heading back to the moon is to build a better spacesuit. This is shelter on a very personal level, their first defense against the extreme and hostile environment. Joe Cosmo and his team have been building the next generation of suits based on lessons from the past.
I think one of the more interesting materials we developed specifically for the shuttle program was the outer layer of the thermal micrometeoroid garment. We call it orthofabric, and it was a blended weave of 3 materials. It was Gore-Tex, Nomex, and Kevlar. It was very tough stuff.
Tough, yes, but mobility has always been a problem. Even before orthofabric, the Apollo suit's limited range of motion made even the simplest tasks awkward.
The suit was quite stiff, and it took a lot of effort to bend it and to use the gloves. That was the most serious defect.
An entry hatch similar to a spaceship's could make dressing a snap.
Heels feel okay?
Yep. Reduced gravity, of course, you can essentially float into it. Close the hatch and secure it, and basically you're in your suit ready to go.
The helmet's on and locked. Okay. Bring
The design team tests prototypes not just for mobility, but also comfort.
If you lift your arms, does that relieve that pressure?
Oh, yeah. If I do this,
so if you do
it's
that,
not contacting.
Okay, so it's just when the way you have it positioned.
They need a spacesuit that can walk, bend, and kneel for days, weeks, or months on the moon. The experiments are ongoing. But for even greater mobility, the astronauts will need something else. New wheels for their local commutes. 30 years ago, the Apollo moon rover helped NASA break exciting new ground.
Without it, we would not have made any of the major discoveries that we made on our mission, and I think that goes also for the Apollo 16 and 15 missions as well.
Oh, spectacular, just spectacular.
The original Apollo rovers were one-time use. They basically landed with the crew used them during that 3-day mission, and then they were done. Almost like a disposable robot.
This time around, engineers are designing a robotic vehicle, a brand new generation of lunar dune buggy.
Vehicle is enabled.
They call it Scout.
Backwards.
As each new crew arrives on the moon, Scout will be standing by, ready to go.
Forward, reverse, left, and right. All right, we're ready to go. Disabling brakes, disabling commanding. Let's bring it down.
Coming down.
Unlike most cars on Earth, this one-of-a-kind $600,000 vehicle is built to last.
Even if they don't land at exactly the same site next time, you could also send the robot to go drive to the next location. So you don't have to keep sending them every time. All right, Jeff, when I get to the field, I'm going to head for waypoint 1.
We'll sequence through waypoint 1, then to 2, over.
Scout runs circles around the old rover. It has touchscreen computers and built-in navigation.
3 meters.
Roger that, Jeff. We should be at waypoint 1 now. All right, vehicle's enabled. Powering the motors. Releasing brake. Max motor temp's about 41 degrees, so we're still in a good range.
Roger that. Moving to 2.
Scout can hold 2 people, travel 9 miles per hour, and carry over a ton of equipment.
Vehicle has arrived at waypoint 2.
Roger that. I confirm a successful track.
The rover can also be driven remotely by voice commands.
Motion stop. We also have added autonomous driving, where you can tell the vehicle, drive to this crater or drive home, and that's all you have to tell it. It knows enough to guide itself back safely.
Scout's eyes are 2 cameras mounted in front. With depth perception, its computer analyzes distance in real time.
All right, going forward again.
When a person moves in front of the vehicle, Scout tags along at a safe distance.
You're out working on rocks or doing things, it'll follow you, sort of like a little puppy following you around. So when you get done with your work, you don't have to walk back to wherever you started to get back on your car. The car's followed you the whole way.
And if no astronauts are nearby, robotic steering can be done through a navigation system known as ACES. From terrain to temperature, ACES creates an enhanced virtual landscape.
ACES for Rob.
All right, Jeff, all the motors are powered, and as soon as you give me the word, I'll enable the vehicle and you can drive it to waypoint 1.
We're disengaging brakes in 3, 2, 1, mark.
Roger that. Vehicle is now enabled. You're ready to go to waypoint 1.
Okay, moving to waypoint 1. 3, 2, 1, motion.
Roger, vehicle motion.
Multiple angles give the operator a panoramic perspective.
Looks like I'm going dead ahead here.
And confirm vehicle stop.
His base camp shows you 0.35 meters off target. That's awesome, over.
In the future, this technology may also guide individual astronauts across a virtual landscape.
We might use a system like this in the visor of the helmet. And so literally as I'm walking along, I can see that blended with the live view, and as I naturally look out. I don't have to look down at a map and look up, figure out where I'm at. It's just part of my natural view.
The view from the moon will be dominated by a harsh and lethal landscape. That's why field testing on Earth is so critical. A well-defined meteor impact crater in the Arizona desert is the closest thing to the moon on Earth. It's surrounded by coarse volcanic rocks.
It has some fairly sharp rocks and fairly good slopes, so it gives us an idea of how rough a surface might be, and also gives us some idea of what kind of mobility we might need for our spacesuits, as well as how the robotic vehicle would operate on a terrain such as this.
Here, several NASA teams converge to check the state of mission preparations as deadlines approach. Together, they call themselves the Desert Rats, an acronym for Research and Technology Studies. Now, at last, theory meets reality.
It's either in or it's out.
Today, the Rats are making a dry run of a moonwalk, a test of spacesuit, rover, and navigation systems combined.
You are right here. The green here, command enabled.
If that is green, it means that you can send commands from this machine to anywhere else, okay? Now remember, the other thing is always, this is the first and last button you're always going to hit. You always want to hit that first before you do anything else. This is an explicit setting, so you don't hit it first.
In reverse, if you pull backwards, you move backwards. If you push forward, you stop.
The teams must confirm the equipment stands up to the desert's punishing temperatures and rough, dusty terrain. With each suit weighing in at 200 pounds on Earth, dressing takes some time. Ultimately, the men, the suits, and the equipment must all work in unison. In just a few short years, this technology will become part of the greatest adventure of our age. The 21st century's mission to the moon.
Am I driving?
The risks are huge. The potential rewards of mineral resources and a lunar colony, even bigger.
It's a big moon. Someone has to explore it. Someone has to learn to use it to go beyond. And we can learn about ourselves by going there, and then we can go to the harder places.
The thing that's going to make it exciting is when people actually see us build these large rockets and start beaming back pictures of people working on the lunar surface again and realize that they're getting ready to go to Mars.
It will not be easy, but few things worth doing are.
40 years later, the statement is, well, if you can send a man to the moon, you can do anything, is still true today. I mean, people relate that ability to greatness.
40 years from now, how will mankind measure greatness? For a generation living in space, the future is boundless.